Test for return, lecture 27, and review. All right, so some of you did great on the test, and some people really very surprised me because I was not awaiting some mistakes. And some people really did wonderful, more than 100%, and I'm just say happy and thank you very much for doing that, because that proves to me that I'm not just talking to empty screens that don't have any pictures. It means that we have been spending good time in this class and we have been really learning. So I'm really very happy with that. And one comment that I do need to have today is that you should know, it's on my syllabus that I reserve the right to make the grading scale easier. That doesn't mean that I'm just gonna get everybody to pass because I need everybody to pass. That means that if somehow your grade is very close to a letter grade, most of the time what I do is I try to bump you up to give you the best possible grade that you get for the class. And that's why I do want people to participate as much as possible in the class activities. The cutoff points on my syllabus are for A, B, C, D, F, and you don't have the cutoff points for plus minus because I decide for that. When you're too close really to an A, I'm just gonna give you that grade. I'm not gonna call the cutoff point for an A minus and then now start arguing over that. Can I please have a few exercises to have a better grade? I don't need that. So I give you a better grade if I see that you really got close to it. So when I assign the minus, it's really that you're really at the bottom of the cutoff points that are given there. Um, the other thing that I did mention on my syllabus, I think, is that your lowest test grade is going to be replaced by half of your final exam grade in case this grade is higher than your lowest test grade. So that's an incentive that often helps people. So some people might actually be sitting with a C or even an F in the class, but because of that rule, a very good final exam pushes you even 2 grade letters up. So you need to know that if you are not in a good shape in the class till now, then make sure you work fine on the final exam. The drawback though, for those who work very well and relax at the end, that same final exam can drag you down, right? So you need to be very careful. Now, speaking about the problems that we had on the test, that was the first one. Use the definition. And now I wanted to write the in French, so I already started. Use the. So that's a French word there. So I'm just gonna add nation, right? And then we're gonna put the English the right here. So use the definition to compute Laplace transform of t f of t e to the t. So that's what it is. And the question is to know first, do you know the definition of the Laplace transform? 1 and 2, how do you use it? So the Laplace transform of t e to the t by definition is integral from 0 to infinity of t e to the t times e to negative st dt. That's what is called the definition. It's nothing else. Anything other than that, you get 0 for the question because that's not the definition. And I repeated this enough during the class. So now how do you compute this? You bring the t e to the t's together. So that's t e to negative s minus 1 t dt. And then we compute this integral by parts. And so that's going to be t e to negative s minus 1 t over negative s minus 1 from 0 to infinity minus integral 0 to infinity e to negative s minus 1t over negative s minus 1 dt. this is equal, when you plug in infinity, this part is 0. When you plug in 0, this part is also 0 because of t. So minus minus, that gives you 1 over s minus 1. And the integral that remains is also e to the negative s minus 1t over negative s minus 1. And then you plug in 0 and infinity. When you plug in infinity, you get 0. When you plug in 0, you get minus 1 over s minus 1 squared. And the minus from the fact that it's the bottom, it gives you 1 over s minus 1 squared. So that's the answer. And the condition for all this to work is that s is larger than 1. Otherwise, the limit when t goes to infinity is not going to be 0. So that's the condition, and that's how you use the definition to find the Laplace transform of t e to the t. In the second question, though, the question was just find the Laplace transforms. So no need to be taking integrals. But if you want to continue taking integrals there, that means you feel you have enough time to finish all the problems that are on the test. Okay. So find the Laplace transforms. And the first one was a f of t equals t sine 2t. This is a common derivative of Laplace transform problem. So that's minus derivative with respect to s of the Laplace transform of sine 2t, which is minus derivative with respect to s of 2 over s squared plus 4. And the derivative of 2 over s squared plus 4 is negative 2s. 2s times 2, that's 4. And the minus, that's plus 4s over s squared plus 4 squared. That's it. That's all you needed. Now, if you want to use something else to answer that question, that'll be you wasting your time, because anything else is going to take you more time than this. F of t equals cosine hyperbolic of 3t minus sine of 2t. And this is a direct problem, nothing even to do here. So Laplace transform of f of t, just write down what the answer is. That's s over s squared minus 9 minus 2 over s squared plus 4. That's it. C, the question was f of t equals t squared e to the t, and it's clearly seen that that's minus u of t plus 1. And also right there, that's clear what you have to do. There's no other work to do. Laplace transform of t squared e to the t, translation theorem. That's t squared. The easiest thing to do is to do first translation theorem. Laplace transform of t squared is 2 over s cubed, translated by e to the t, s minus 1 cubed. That's it. Minus Laplace transform of u of t plus 1. That's 1 times u of t plus 1. Laplace transform of 1 is 1 over s times e to the s, because it's translated. So that's the second translation theorem. And that's it. That's the answer. And D, we had f of t equals t u of t minus 3. So this is a problem where you need first to write as u of t minus 3. So that's t plus 3 minus 3, u of t minus 3. So that's the Laplace transform that you have. So the function is t plus 3. That's the f of t. F of t. And here, therefore, you got f of t minus a. So this is f of t minus a, u of t minus a. So f of t being t plus 3, the answer is Laplace transform of t plus 3 times e to the negative 3s, which is Laplace transform of t is 1 over s squared plus 3 over s times e to negative 3s. That's it. That was question number 2. Now question number 3 was find the inverse Laplace transform. And so the first one was A, inverse Laplace transform of natural log of s minus 2 over s squared plus 4. So here we said in this class, this is going to be negative 1 over t derivative with respect to s inverse Laplace transform of natural log of s minus 2 minus natural log of s squared plus 4. And that is negative 1 over t inverse Laplace transform. The derivative of natural log of s minus 2 is 1 over s minus 2 minus the derivative of this one is 2s over s squared plus 4. Therefore, the answer is negative 1 over t. The inverse Laplace transform of the first one is e to the 2t minus 2 cosine of 2t. So that is equal to 2 cosine of 2t minus e to the 2t over t. That's it. And in B, the inverse Laplace transform of s minus 1 over s squared minus 4s plus 5. It's only one thing to do, nothing else. If you want to factor out that denominator, you're going to see that that is s minus 2 squared plus 1. It doesn't factor out. That's the only thing you can do. And so right there, you see that you have the second translation, you have the first translation theorem by s minus 2. So it's going to be e to the 2t first, then inverse Laplace transform, and you replace s minus 2 by s. So that becomes s plus 1 over s squared plus 1. So you replace s by s plus 2 or s minus 2 by s. This is where you get. And therefore, this answer is e to the 2t times cosine t plus sine t. That's it. And then you get to the fourth question. And the third question was, use the convolution theorem. Find the inverse Laplace transform of s squared over s squared plus 1 squared. This is equal to cosine t star cosine t. That's integral 0 to t cosine tau cosine t minus tau d tau. Right, in this class, I gave you what needed to be done for that. You don't want to do that and you want to integrate otherwise, make sure you do it properly and learn that first before you get to the exam. Things like that are going to repeat, and if you're not willing to do what we do here, you need to make sure you learn something else to make sure you don't get 0 on the question. So how do we integrate this? What I proposed was to write cosine, the product of cosines, as the sum of cosines. How do we do that? The suggestion was that cosine of a plus b, that's cosine a cosine b, minus sine a sine b. Cosine of a minus b, that's cosine a cosine b, plus sine a sine b. Now, if you add these two things, you can get that cosine a cosine b is 1/2 of cosine of a plus b plus cosine of a minus b. If you can't memorize that formula, perhaps you can derive it this way. So that's what it is. And so in our case, a is tau, b is t minus tau. So a plus b is t, and a minus b is 2 tau minus t. So we end up here with 1/2 integral from 0 to t of cosine t plus cosine of 2 tau minus t d tau. That's it. Now you compute this integral, that's 1/2. The integral of cosine t d tau, that is cosine t times tau, and the integral of cosine 2t, that's 1/2 sine of 2 tau minus t. And then you plug in 0 and you plug in t. And this gives you, when we plug in t here, we got 1/2 t cosine t. When we plug in 0, we get 0. Now when we plug in here t, we get 2t minus t, that is 1/4 sine t. When we plug in 0 and then we minus, that'll be minus and minus plus 1/4 sine t. So the answer that you are getting is 1/2 times t cosine t plus sine t. That's it. So now we are left with question number 5. On question number 5, we had to solve applications of Laplace transforms. And the first one was solve a second derivative minus twice the derivative equals 1 y of 0 equal y prime of 0 equals 0. And specifically chose that problem to make sure you don't have many issues with partial fractions. So just making the things easy by giving you zeros and then eliminating the term here. Now, what you do need to do is to get those Laplace transforms. S Laplace transform of y minus y of 0. Make sure you get the right answer. So that's S Laplace transform of y of 0 is 0. So Laplace transform of the second derivative is S Laplace transform of y prime minus y prime of 0, which is also 0, so that's S squared Laplace transform of y. We got them all, so S squared Laplace transform of y minus 2S Laplace transform of y equals Laplace transform of 1, which is 1 over S. And so here we get Laplace transform of y equal 1 over S squared times S minus 2. Now, at this point, it depends on you. Whatever you want to do is what you do to finish the problem. You can do convolution theorem. You can do partial fractions. It's up to you. Whatever you like the most is what you do. I do convolution. So I get y is equal, this is 1 over S squared times 1 over S minus 2. And 1 over S squared is t star e to the 2t. So that's what the answer is. And so you just need to do that convolution. Integral 0 to t of tau e to the 2 times t minus tau d tau. And then you integrate by parts. So that is tau e to the 2 times t minus tau over negative 2, 0 to t minus integral 0 to t of e to the 2 times t minus tau d tau over minus 2. When we plug in t, this exponent turns to 0, so we get t minus t over 2. When we plug in 0, tau is 0, so that's minus 0. Now here we get minus plus, so that's plus 1/2, and then you integrate this thing again, that's e to the 2 times t minus tau over minus 2 again from 0 to t. Now when you plug these in, you got negative t over 2. When you plug in t, again the power there turns to 0, and this is minus 1/2 times 1/2, so that's minus 1/4. And then when we plug in 0, we got e to the 2t, a minus, and this minus becomes a plus, so that becomes plus 1/4 e to the 2t. So we end up with y of t equals negative 1/4 minus t over 2 plus 1/4 e to the 2t. And if you go do your partial fractions, you spend more time, but you end up with that same answer. Now you can check. You can check that actually y of 0 is 0. If I plug in 0 for t, that's how you can check your answer often. I plug in 0 for t, this is 1/4 minus 0 minus 1/4, that's 0. If I take the derivative of this function, I get negative 1/2 plus 1/2 e to the t, 2t. If I plug in 0, also I get 0. So the initial values are satisfied. And definitely this function is a solution of that problem. So that's the unique solution of the problem that we got. And that's it for part A. And now for part B, we have the integral differential equations that we used. So 0 to t, f of u du plus f of t equals t. To answer that question the same way, you do the Laplace transform on both sides. Laplace transform of the integral to t f of u du plus Laplace transform of f of t equals Laplace transform of t. And that gives you Laplace transform of the integral. That's 1 over s Laplace transform of f of t plus Laplace transform of f of t equals 1 over s. And I think this was the easiest problem of the test. But somehow most of you didn't answer. So here, this is 1 plus s over s, Laplace transform of f of t equals 1 over s, where you get Laplace transform of f of t equals 1 over s plus 1. Therefore, f of t equals e to negative t. That's it. End of the test. That took about 28 minutes. Questions? Your questions, please. The silence is welcoming me. So what we do? We just look at each other, or no, I look at you and you look at my paper, or we continue? Any questions at any point for this class from the day one till now? Anything that you want me to talk about? Some people got 110 or 11 on this test. Silence. All right, if you guys want to continue the silence, let me give you a problem. Exercise. It's more about you practicing all of this now. Solve integral 0 to t f of tau d tau minus 2 f of t equals I think I have a problem somewhere here. This is here with 1. And I got no question, right? So please take a few minutes to do this one. With t here, the Laplace transform of t is 1 over s squared. Who's ready for the answer? Let me not ask like this. Can you, James, please go with me through the answer? This is a better question. James, can you hear me? Do we have two people by the name James in this class? Can you please go with me on the details of this? I don't know if he hears me.
Are you talking to me?
Yes.
Sorry, my Zoom connection's really bad. It's freezing on me.
I'm asking if you can go with me on the.
All right, so
What was the first
I
step?
did the Laplace transform of
Mm-hmm.
I just did the Laplace transform of the integral t to 0 of f of tau d tau.
Which is?
Minus 2 Laplace transform of f of t equals Laplace transform of t.
What is this Laplace transform equal to?
I did 1 over s Laplace transform f of t.
That's it. Equals?
And then the minus the 1 over s squared.
That's it. And now you can solve. So that's 1 over s minus 2 Laplace transform of f equals 1 over s squared. And from there, you can solve that the Laplace transform of f of t equals, you bring this the common denominator, the s cancels, so you get 1 over s times 1 minus 2s. This is what you get. And so here you can either do the partial fractions or integrate again, doing convolution theorem. So it depends on you. Do whatever you want. All right, so on this one, I say it's easy. I want to do partial fractions. This is how I do partial fractions. So I put here plus plus, and I know 1 minus 2s is going to go on top, and then I'm going to have s here. So minus 2s plus s, that's not going to be 0. To have 0, I need a 2 here. So if I have 1 here, I'm going to have minus 2s plus 2s. They will cancel, and then I will be left with 1 over s times 1 minus 2s. Perfect. So the answer is right there. That's how you can do easily when it's just two things like that. So that's what it is, and therefore f of t is the inverse Laplace transform of 1 over s plus, and this is 1 over 1/2 minus s, or okay, this is Laplace transform is 1, and 1 over this is minus e to the 1/2 t. Ta-da! Now the very question we had on top, if we had that problem with t instead, and we're starting the problem that we had on top. f of u du plus f of t equals t. Then in the Laplace transform, the difference will be that you get s plus 1 over s. Laplace transform of f of t equals 1 over s squared. So in this case, you would have Laplace transform of f of t equals 1 over s times s plus 1. And this you can just do as I did the one on top here. You put over s plus 1, 1, 1. To get s to disappear, I need a minus here. So I just put that minus there. I know s minus s, they cancel and you remain with 1, 1 over, oh yeah, perfect. Right away. So you got your partial fractions. And therefore, you can go ahead and find that f of t equals, that's 1 minus e to negative t. That's it. Any questions? You don't have any question? I got a lot of questions, so you just gotta keep asking. Next exercise. Solve the following linear problem. X, y double prime plus 2y. My pen is angry. It doesn't want to write anymore. So I'm changing. So that's xy double prime. I'm sorry, xy prime plus 2y equals x to the power 5. And then it says solve the following linear problem. You got 5 minutes. We are already reviewing for our final exam. All right, can I get Mr. Preston to work on this with me? Step one, what do we do?
So I was looking at the Coley-Euler equation.
Yeah. Cauchy-Euler equation is for linear equations with fixed coefficients, and I said here solve the linear problem. That's a first order linear problem. And you got an x here, so you don't have fixed coefficients. Aline? Is she with me? Ethan?
I believe this is the one where we multiply everything by mu of x and then solve for it.
You're right, but before multiplying, there is a first step.
You have to divide everything by x.
Great. So that's it. Y prime plus 2 over x, y equals x to the fourth. And then we do what you just said. Multiply the whole equation by mu of x, y prime 2 over x mu of x, y equals x to the fourth mu of x. And then what do we do after that? We find mu of x, right? What's the formula for mu of x? Hello? I'm still with you, Ethan. What's the formula for mu of x here?
Mu of x equals e to the integral p of x dx, where p of x is what is with y.
Great. So that is p of x. So this is e to the integral of 2 over x dx, which is e to the 2 natural log of x, which is e to the natural log of x squared, which is x squared. So that's the integrating factor. And what's the step that we have after this, Messi? I think I just lost somebody because I'm asking questions. Hello? What's the step after finding mu of x?
Don't you plug it back
into
into
the original
the equation?
And then we do what to the left-hand side?
You factor out, so it would be d over dx of x
D
squared
over
y.
Great. That's what we do. Equals, and then x to the fourth times mu of x, which is x squared equals x to the sixth. That's the next step. Now, what's the step we have? What do we do?
Integrate both sides with respect to x.
Integrate both sides with respect to x. And when you integrate the left, what you get is exactly what is inside this. Always x squared y equals, and this integral is 1/7 x to the 7th plus the constant of integration. Then you solve for y here. Y is 1/7 x to the 5th plus c over x squared. That's it. Thank you very much. And the next thing would be solve the following Bernoulli equation. You can't miss something like this on a final exam. That wouldn't be my class. So here, want to solve the Bernoulli equation. And say we got y prime is 2y equals x squared y, let's say y cubed, cubed. And I'm waiting 5 minutes, and we go. Who's ready to do this? I always forget about this, that I should just ask. Can William help me with this?
I can help slightly.
Oh, let's go. We all try, man. We don't care for not having the right answer. We all learning.
Okay, so you set it up here. So you're going to divide by y cubed
Good.
on both sides to begin.
Mm-hmm.
And that's going to leave you, yeah, right.
What next?
And then your W value, I believe, is going to be 1 over y squared, your
Correct.
Brodsky value.
Correct.
And then
Just one
dw, what was that?
Just one correction. This is W, but it is not the W that we call Vronsky.
Oh, yeah, you're right. My bad. And then you take the derivative of W with respect to X, right?
Yep, that's right.
And what would that be?
Here it's gonna be minus 2 over y cubed dy over dx. Power rule and chain rule, right?
And that's as far as I got.
Mhm. Now all you need to do is take these things and substitute in the problem. You take this guy, it's in the problem, it's that. You take this guy, it's this guy here. So you take them and you substitute in the equation. So this is gonna be, this piece is minus 1/2 of that. So this is minus 1/2 dw over dx plus 2w equals x squared. Like my daughter says, I'm done. Now you continue. What's the next step from here? Next step from here.
You have to find mu.
Before finding mu, what do we do? We go back to the previous problem. At this point, it's exactly the previous problem. So what?
Oh, you have to put it in standard form.
That's right. So standardize. So here, what are we gonna get?
So you divide the whole thing by negative 1/2.
Yep. That's what you get. Now is where I agree with William that we got to find the integrating factor. Multiply that whole thing by mu of x dw over dx minus 4 mu of x w equals minus 2 mu of x squared. And mu of x, what is it equal to here? E to the yellow.
E to the negative 4x.
Yeah, but you gotta tell me first integral of
Negative 4 dx.
good. And so that's e to negative 4x. And so that left hand side becomes d over dx of e to negative 4x y. So, well, again, it's correct what I wanted to write, but we don't need that. So w equals minus 2x squared e to negative 4x. Then we go to step 5, which is integrate. And that's going to be e to negative 4x. W equals integral of minus 2x squared e to the 4x e to negative 4x dx. And then you compute this integral. I'm letting you, please take your time and compute this one. And so I'm going to step 6. You're going to have w equals 1 over y squared, in this case, equals 1 over, and then that 1 over, we can turn it into e to the 4x. And now you tell me what that integral is, and I put it inside here. Please take a minute to compute that integral. What is the integral equal to? Twice by parts. Got that, Mason?
I got x squared e to the negative 4x over 2 plus x e to the negative 4x over 4 minus e to the negative 4x over 4.
Give me time to write what you're saying. Yeah,
I got plus x e to the negative 4x over 4
looks like it. And then
minus e to the negative 4x over 4.
then
Plus c.
yeah, that's the very important part that you should never forget. I can forgive you anything, but not that c. So e to the negative 4x times e to the 4x, that's where you get 1/2 x squared plus x over 4 minus 1/4 plus c e to the 4x. That's the answer. 1 over y squared equals that. So now we've reviewed the linear first order problem, Bernoulli problem, and we've discussed more Laplace transforms. And I'm going to ask you to do exact equations now. Yeah, yeah, yeah. So, and I told you the equation is exact, so you don't need to waste your time showing that it is exact. Just solve it. All right, who's ready for the last solution? After this, we say bye. Who's the hero? Who's the hero? Step one. You want to be the last person standing. Who will give us the honors, please?
Since you already told us that the equation is exact, we don't have to prove it. So we can just go into the fact that the integral of m dx equals f of x.
Yeah, of xy equals integral of m of xy dx, where this is m and that is n. And so that's integral of x squared y plus 1 dx. And this, what is this integral equal to?
1/3 x cubed y plus x plus some function of y.
Good. And you do remember that when you're integrating with respect to what x, y is a fixed constant, so you don't integrate, it just stays where it is. And the second step, what do we do?
To solve for that function of y, you can take the partial derivative of the f that we just found with respect to y and set that equal to n.
Correct. So that derivative is
1/3 x cubed plus h prime of y.
that's it. And then we set it equal to n of xy, and n of xy in this case is 1/3 x cubed plus 3y. And you solve, you get h prime of y equals 3y. So this goes to cancel with that. And then the next is you'll find h of y as the integral of h prime of y dy. That's integral of 3y dy. And now y is the parameter of integration, those 3/2 y squared plus a constant of integration that does not depend on anything now. And then we take this h of y back to the formula of f of xy equals 1/3 x cubed y plus x plus 3/2 y squared plus c. And then never forget about the last step, set that equal to 0. And that's what the solution is. Any questions? All right, if at this point there is no question, then I'll say thank you very much for listening to me today, and I see you next time.
Thank you,
Thank-
Dr. Longworth.
All right, thank you.